Please welcome Sherry Williams.
Good afternoon, everyone. A little bit of a frog this afternoon. Thank you for joining. I know we're kind of getting to the tail end of the 2 days, so I appreciate all of you taking the time to join us here this afternoon. Before we get started, I kind of want to do a little visualization kind of exercise. So if you can close your eyes without going to sleep, go ahead and do that. But just kind of imagine with me, Antonio had a really outstanding keynote yesterday and shared all these incredible announcements and all this exciting stuff that we've been innovating on as a company. And so I don't know about you, but I know when I'm flying home tomorrow, I'm going to be thinking about all the cool things we could be doing and all the advancements I want to do, and this I want to do with this team and that team and so forth. So I imagine something like this for each of you might be thinking about, what does great look like when you get home? Great for me looks like my teams are agile. They can adjust to the industry shifts really quickly. There's plenty of industry shifts right now. My costs are stable. I can predict what they are. That would be amazing. My distributed teams can access the data that they need, only the data that they need, in a secure manner. And that all my workloads are running in an appropriate place, optimizing cost, security, and privacy. Now, if we snap back to reality, that's certainly not what it looks like for me, and I'm sure that's true for many of you as well. Our workloads, many of them are running in the wrong place. Legacy systems, so forth, the workloads are running in places that are arguably too expensive, raising the costs unnecessarily. Our data sets are all over the place. The data sets that you need to actually drive AI, they could be in the cloud, on-prem, at the edge, in the colo. Depending on where they sit, there may be different security requirements. There may be different privacy requirements for that data and accessibility issues. Our teams spend a lot of time managing legacy IT environments rather than having the time to innovate on new and exciting things. I was just in a roundtable upstairs, and that was a topic that came up of spending a lot of time on the legacy things and not having the right balance of being able to work on the new, innovative things that change the business. I'm guessing that all of you can relate to at least one of those, if not all three of them. I think all of us are challenged with trying to figure out that right balance day by day. It's all about really looking at costs, compliance, especially with respect to data, and performance. So if we start with cost and look at it, again, going back to the workloads, if the workloads are not running in the appropriate environment for that workload, your costs go up significantly. If you have a lot of things in the public cloud that may not belong there, your costs are going up significantly. You're running old systems and new systems side by side, but they're not unified. You don't have the benefit of actually a unification of those systems. Many times you can't see your whole ecosystem from an operational point of view, making it very difficult not only to manage it, but predict the costs, predict behaviors, predict what might be coming in that environment. HPE faces the same challenges. I work with HPE IT on a regular basis, and we face the same challenges you do. We all need a predictable environment that we can manage costs effectively. But we're all saddled with the problem of workloads being all over the place, a set of disparate tools, and figuring out how to balance bringing that all together in a way that optimizes your costs and enables innovation to happen. A lot of that innovation is data-driven. In fact, a lot of the legacy is dependent on data. We are all responsible for managing the data that is in our environments. As you all know, that data is everywhere. Again, in the cloud, on-prem, in the colo, on the edge, and the data sets keep growing and growing and growing. Each location frequently has different rules, different security models, and many times there's different interpretations of what compliance actually means. Regulations continue to expand no matter what country you're in, and privacy expectations continue to grow. And as you all know, complexity increases every time you inject a new application or workload into the environment, which then generates another data set, and the complexity spirals on itself. We as leaders, we all want governance that applies once across all of your ecosystem. The problem is, without a unified approach, compliance actually adds friction into the environment rather than building confidence. All of our teams are under pressure to deliver outcomes, and lately, especially AI outcomes. But that's again challenged for our teams by the diverse nature of the environments, the ecosystem, the challenges that they deal with on a daily basis with respect to tools and data. Pipelines drift regularly. Applications run differently from one location to the other, even though they're not supposed to. It frequently happens. When these environments are not consistent, schedules slip, risk is injected, and innovation slows down. What is needed is a consistent experience that enables teams to move quickly, to be able to innovate, and to inject predictability into the system. So every one of you, I'm sure, can relate to wanting to have that trust that in every location, your data is secure, your costs are managed and predictable, and that you can operate in a manner that balances legacy with future innovation. Every leader that I meet with personally, that is part of the conversation that we have. Everybody's looking for the path to that state and how they're going to get there in a way that balances the budget, meets the business needs, and drives innovation. Now, if you think about companies that are doing it well, I would contend that most of them are figuring out the right balance of cost, compliance, and performance. Many of them are actually doing so in a hybrid cloud environment, building their own private clouds on-prem. The modern private cloud delivers one operating model across your entire ecosystem. It allows you to have predictable costs and clear governance. It allows you to have consistent performance so that your teams can move faster and you can actually scale with AI. And it gives you control over data, ability to move data where you need to understand the data you have and curate the data you have. This private cloud that I'm dreaming about is not the private cloud of 10 years ago. This current new private cloud, or the modern private cloud, is all about unification. Unifying how you operate, unifying how you secure your data and your workloads, how you accelerate workloads in a hybrid world, how you bring it all together, balancing working in the public cloud, on-prem, at the edge, and the colos. HPE has built a private cloud portfolio addressing those capabilities and those desires. It's not just a collection of products. It's a set of capabilities, mindfully curated, that help you modernize at your pace, at the pace of the industry, that strengthen your governance and simplify your operations. The HPE private cloud brings together all of the capabilities that you need to drive cost, compliance, and performance capabilities. Now, I'd like to make this real for you this afternoon. We have a couple of customers that you're going to hear from who have transformed their businesses based on these principles. One of the customers has built the control and agility that's required to manage 80,000 simulations a day while still meeting the European regulatory requirements. The other customer is focused on very critical healthcare research, focused on using AI to accelerate the delivery of scientific discovery and treatments, using very sensitive clinical and research data. Two seemingly different worlds, very similar challenges. Same underlying foundation for success. So before I bring them on the stage and talk more about them, I want you to think individually about, either in your IT environment or in your personal life, a system where if the system is not accurate, if the decisions made by the system are not accurate, human lives and safety are at risk. Bosch, one of our first customers today, lives in that world every single day. Bosch is building systems that must make the right decision every day or human life is at risk. Think about autonomous driving. When you think about autonomous driving, what do you imagine? A world that you can get in the car and go to work in the morning while reading your email, responding to email and text messages, or maybe watching a football game, or maybe putting your makeup on? That's actually not the vision and the mission that Bosch has for autonomous driving. There is all about safety, and safety for every single one of us. Every single one of us. It's not about convenience, it's about safety. Autonomous driving is really only safe, if you think about it, it's really only safe when it's available to everybody, regardless of the kind of car you drive or the market you live in. Bosch calls this democratizing autonomous driving. So what we're going to have today, we're going to bring up in just a second Thomas Clausen from Bosch, and we're going to talk about the work that they've been doing to make it so that autonomous driving is something that is accessible to all of us, regardless of, again, the market that you live in, the type of car you drive, regardless of the weather that's out there, the animals in the way, all those things are taken into consideration when they're building out this model. In order to do that, if you think about the data piece of it, the data that they use to build this is absolutely critical. Understanding what data sets are needed to do this is absolutely critical. And understanding the privacy requirements, the security requirements, and the compliance is absolutely critical. So without further ado, please welcome me in joining Thomas Clausen, who leads Bosch's automated driving program.
Hi, Sherry.
Thank you. Thank you for
Thanks
joining.
for having me.
Oh, so grateful that you're here. So let me get my notes here. So, as I've noted, Bosch has been leading safety for decades, and it means a lot to have you share this story. I think it's a fascinating story. Can you take us into the mission a bit?
Sure. The Bosch mission is technology for life. Bosch has a history of more than 130 years of building new inventions for the car industry. We're the world's largest automotive supplier. We've brought to the market systems like ABS, ESP, in the 70s, in the 90s, the automated emergency braking system at about 15 years ago. And all of these innovations we can see later on in the statistics, in the accident statistics, really reducing the fatalities on the road globally. And this is the mission which drives us, making driving safe for everybody across the planet, independent of the country, of the region, independent what car you drive, not only the luxury cars, it should go in every vehicle. This is what drives our engineers and what is the motivation, and this is also the mindset of the development, bringing safety to the road.
I'm so grateful you focus on that. How does this idea of democratizing autonomy guide the choices you and your teams make on a daily basis?
Yeah, for us, I mean, safety is the primary goal to access. And then bringing the systems to the market means we have to make the system cheap enough, available enough, so that they can be used in all of the vehicles. It's very, I wouldn't call it easy, but it's more straightforward to have a system which is safe, which relies on a lot of sensors all around the car, but really bringing it into smaller systems, taking it everywhere, that's the mission. That's why we are also taking partnerships, for example, with Carriot, which is a Volkswagen VW subsidiary. This is a company producing 10 million vehicles a year, so this is a possibility for us to scale into all kinds of vehicle classes. And at the same time, you talked about the data, retrieving data back from the field, which allows us to improve the functionality even better based on real-world data.
Data is so critical, always about data.
Yeah.
So what I hear in all of this, scale and responsibility. When safety is the mission, your foundation has to have both scale and responsibility. To support a mission at the size, you built a sovereign private cloud in Frankfurt.
Yeah.
What did you need that environment to do for you so you could move fast and still address the safety and regulatory constraints?
Actually, it started from the safety side. We want to test all of our systems before we send them out. Theoretically, the easiest way to test these systems would be in a real vehicle, but this is not what we want to do. We don't want to make drivers being the guinea pigs of the test. So we have to mimic the car in a closed environment. The typical way to do so is you build benches where you have the real sensors, the real ECUs, we call them the control units, running the systems and testing what is happening. Now, we have designed a way to develop very fast. That's why we moved to the cloud, initially to the public cloud. But then what you do with the test benches? You have to bring the cloud and the data together with the test benches, and that was the initial idea, to bring this together in a colo in Frankfurt in our case, because a lot of our data comes from Europe, and there, as you probably know, there are strict regulations on GDPR, on data privacy. So we have to keep the data locally in Europe, and bringing this together in Frankfurt was the first step. And this we did together with HPE, with a very good team of yours, delivering in time, but even more than delivering, really working together as a common team, as a partnership, doing that together, bringing that to life and making this available, what you just mentioned, these 80,000 tests a day in this setup. But that was then only the beginning, you know, to continue. And we had this system now there, doing what we call the right side of the V, so the verification, the validation. And the question was, can we do more of that? Can we also do the initial training there? Because you mentioned it, there is some cost involved with the public cloud. Of course, Bosch would never exceed the cloud budget. We would never do so.
I'm sure no one else
no,
has.
Definitely not. But obviously there is cost involved, and there was, from a cost perspective, but also from this sovereignty perspective, the question, can we also move those workloads into this co-location and extend what started to be a co-location into something which in the end going to be a private cloud? And yes, we did so. We had the kickoff in July, beginning of August this year. The system is up and running and is productive by now.
I'm so happy to hear that. You talked about how important we've talked about how important data is. How do you decide what data matters, what moments you need to capture, and how that partnership helps you build solutions that are reliable and affordable?
I mean, for us, speed in the end is a decisive factor. It's about also what the developers can experience. We have in total in this program 1,000 developers working on the system in parallel, and they do their trainings. They want to run systems which work. We need those systems to perform every night to do the tests. This has to be continuously flowing, continuously working. And this reliability is one of the key factor to do so. And of course, and then it's cost. And in the end, it's all about speed. Everything which is not working nicely is reducing the speed which we have. We see a massive increase in this industry for more speed. Recently, car manufacturers took like 3 to 4 years to bring new vehicles to the road. Now this is reducing to 1.5 years. So we have to capture this speed, and still we want to progress in functionality. We want to get better features, more safety into the vehicles, so continuously increase that, and that is only possible if the systems are running and if we are able to increase our development speed, and this is only possible in such a setup.
Well, and it's amazing to think that you can actually produce a new car in 1 to 2 years.
We don't produce a car, we just do the safety functions.
Well,
but the automated driving, yes.
You know, it's amazing to consider that. So how do you take a real event on the road, with the car, something that's happening on the road, and carry it through your simulation and validation process so you can release updates with confidence?
So the process works like this. We have a functionality out there which we monitor, which we see. So far the functions which we have, there's always a driver still in the loop. We can monitor those situations where the driver is actually not happy with the functionality because he's taking over or steering by himself or whatsoever. And this is a good indication that here the system is not perfect. And we can take these situations back into the backend, in this case to the cloud, to the private cloud. We can analyze these situations, and we can go out there and search for more of a similar type, actively searching, creating data which we transfer back. Of course, again, all of this data is potentially privacy related, so we have to treat that very carefully. We don't allow many people to really inspect the data. It's more the machine which is inspecting the data. But then we can use this for the training. We can create simulation on top which mimics such situations, and this creates then the basis for the new version, which then goes under test and eventually goes into the vehicle.
That's totally fascinating. We talked a little bit about this yesterday, of the amount of data that you can capture is significant. Knowing what piece of that data is relevant to what you're doing and the stuff that you don't need is a critical piece of efficiency.
Absolutely. If we were to collect continuously, we would produce in each vehicle about 10 gigabytes of data per second.
Wow.
If you scale that up with the millions of vehicles, absolutely impossible to even collect all that data. So it's really knowing what the right data is in the very moment when you collect, and then even after that, sorting out, curating the right data. That's a good part of the process. Otherwise, not possible.
Otherwise, not possible. So we've talked about the mission, the foundation, and the validation. I want to bring us back to the idea of democratization, and because this is really the heart of what your vision is. Where are you already bringing these capabilities into mainstream vehicles, and what does that change for the safety of all of us in the room and globally?
I mean, for us, this is a continuous process. We are bringing systems continuously to the market with increasing performance. My personal first experience with that was like 13 years ago when I was project leader for a project that brought the first AEB, automated emergency braking system, to, in this case, to the Golf, so to a C-class vehicle. And 1 year later, we learned that from insurance reports, in this case in Great Britain, they actually saw that the rear-end crash numbers for those type of vehicle dropped by about 30% from one model year to the next one. And this is continuously, so we are bringing more of these systems. And now, recently, we have this system running, so we're bringing software from this, now first to test vehicles, and soon also to the real vehicles. And we are starting now even the next programs also with other manufacturers. So not only, in this case, Carriot or VW, but we are having more customers now globally jumping onto this, where we will bring the software to. Which, of course, then means, again, we have to scale up the system here, because what we have designed here is good for the specific purpose, but the next step is even larger than that.
To be able to build. I know that I have that capability in my car, that emergency braking, and it's probably saved me from an accident multiple times, definitely. So you've shown us how this work is making a difference on the road. Let's look ahead a little bit, okay? As you build out this, continue to build out the private cloud foundation that we've worked together on to build, what becomes possible for your teams that might not have been possible a year ago?
Now, with this onset of AI throughout the whole stack which we are building, and with the possibility of these fast training, fast evaluation, we become much faster in developing these systems. We become much more flexible by the method of how we develop that in incorporating very specific use cases, and that drastically increases the capability of these systems. So we're going to see these systems taking over more and more of the use cases time over time. It's not that the system will be fully automized and doing everything next year. This will take quite a bit. But you will see and you will experience in your car, when you buy a new car, or in the new cars even by software updates, that the functionality is continuously increasing and that the vehicle can do more with each step until finally it can do practically everything. But this will take a bit of time.
Well, I have to share with the audience that I have a car that will self-park, and I've never used it because I'm afraid of it. I'm afraid that it's not going to be accurate and I'm going to hit something. And after our discussion before Discover and yesterday, I've committed to going home and giving it a try. So I appreciate that. Let me see. So I want to thank you for your time here. Is there anything last that you'd like to share with the audience?
Yeah, I mean, for us, it's been a bit of a journey to go this together and to create this solution, which was not there before. But for us, it was a very positive experience to see how fast it was possible to implement that, how reliable it is, and also to create something here which is neither a classical public cloud nor a classical on-prem, but something in between, which creates a lot of value first to our developers and for them, and by them then also for our final product.
And I think you mentioned in a different meeting we had in the last day that when your developers moved from, when we had the system up and running, the developers really didn't know the difference between whether they're working in the public cloud or in the private cloud solution that we built together.
It just became faster for them, but otherwise it didn't change.
And that speaks for itself. So anyway, I'm delighted to have the opportunity to talk with you the last few days and look forward to all the incredible things that you're guys going to be building over time.
Thank you.
Thank you for your partnership as well.
Thank you.
So hopefully some of you will try your self-parking capability if you have it. You probably have done a better job than I have. So Thomas has helped us understand what it looks like to build a private cloud and the benefits that can happen very quickly at scale. That private cloud foundation that they've built allows them to put the right workloads in the right place, deal with the sensitive data, the privacy of the data, and run these simulations with confidence, all in a way that is enabling safety for all of us. Now I'm going to pivot to our next customer, and this story takes us in a different direction. This is a story about human health, diseases, and so forth, and the progress that they're making utilizing AI, where there's very sensitive, very precious data involved that needs to be protected at all costs. As you can imagine, pediatric diseases are catastrophic both emotionally and personally. And the work done in this area is extremely demanding work. The stakes are incredibly high. The insights that are gained are critical and really, really important. This is the challenge that St. Jude's Children's Research Hospital deal with every single day. For those of you who don't know St. Jude's, it's a research hospital in the United States that really focuses on children's health, children's diseases, and really well known in the US. And as you'll hear from our speaker, our guest, that they do a lot of work globally with other medical institutions as well. Their teams at St. Jude's are working across lots of technologies, including imaging, genomics, microscopy. The data generated from all those is excessive as well. They push to understand diseases faster so that they can drive treatments and resolutions faster as well for the patients. All that data, as you can imagine, is sensitive and very private. So managing that data, protecting it is critical. Yet they need to move at an extreme pace to be able to go after some of the diseases that face the young people in our world today. They need a private cloud that also gives them consistency, security, speed, and agility. They need their teams focused on research, analyzing the research, not on the infrastructure challenges in the environment. So, without further ado, I'd like to ask you to do a warm welcome for Dr. Sue, who's leading this work at St. Jude's and brings a powerful view of how AI is accelerating discovery in the real world. Dr. Sue? Thank you so much.
Thank you for having me.
So let me get my next set of cards here. As I noted, the work you support changes what's possible in pediatric research and discovery, and it is a real honor for you to be with us and share part of that journey with us today. So can you share how your teams support the science and the role it plays today so everybody kind of understands that piece of it?
Yeah, happy to. I joined St. Jude about 8.5 years ago. And ever since, I've been working with research leadership to not only establish but evolve the team known as the Research Information Services, whose mission is to support St. Jude research. And the team is comprised of multidisciplinary expertise. So we have number of systems engineers, HPC engineers, computational scientists, AI, ML experts, and software engineers, and so on. So together, they develop and provide research computing resource and technology support service to the St. Jude research community. I want to expand a little bit more about St. Jude research and its mission. Right. So right. St. Jude mission is to advance treatments and cure for pediatric catastrophic disease such as cancers through the discoveries we make in laboratory-based fundamental research. Right. So that's our mission. So discover knowledge and translate them into clinical therapeutics for treatments and cures, and also improving after life quality. Mm-hmm. So that's the mission. So St. Jude research enterprise is vast and very complex and diverse. It encompasses wide spectrum of biomedical research areas, such as, for example, I'll give you a few examples. We have radiation oncologists whose interest in developing AI models so that they can use the models to compute and prescribe protein doses. We just killed tumor cells without killing adjacent normal cells. So they're interested in doing, applying AI technologies to do that. And we have also scientists in structural biology department, chemical biology department, and so on, whose interest is in determining protein structure and also develop drug compounds and do AI models to understand interaction between this compound with target proteins so that they can discover new drug. So they are wanting to use AI models for that. And then we have people in the radiology department who wants to mine and apply AI technologies to radiologic images such as MRIs so that they can determine cancer subtypes so that they can not only diagnose but prescribe targeted therapy, individualized therapy based upon cancer subtypes. So our scientists are interested in using AI technologies to not only diagnose but prescribe individualized therapies, effective therapies, and also develop most efficient, effective drug compounds. So,
And in all those technologies and that you just mentioned, I'm guessing a lot of data is generated in that.
yeah.
These data lives across labs, instruments, teams, strict privacy rules like we already spoke about. When you begin applying AI and these rules, what pressure shows up first for your teams? What are the things that they have to really take into consideration first?
Yeah, the first most critical pressure points for our team is governance. So these days, people are wanting to use new AI models, new AI tools, and so on. So we start really vetting and validating the usefulness of those tools and models, and as well as also safety, as well as responsible use of those tools. So we need to have a governance process in place to vet and validate those tools so that we can use that in a safe manner in terms of also complying with institutional policies and legal obligations and regulatory compliance requirements and so on.
So that actually leads very nicely into my next question, because with things like GDPR, sovereignty, HIPAA in the United States, other sort of regulatory things, and you're collaborating with medical institutions around the world, not just in the US. So as you collaborate with partners across Europe and other regions where data is not really allowed to leave the borders, how do you protect compliance and still move things forward, leveraging that so we can have enough data to feed the models to actually move things forward?
Yeah, that's really a great question, but a very challenging question as well. Because as you said, that our researchers do collaborate with other scientists throughout the world. For example, we have a scientist who's doing work with Princess Maxima Institute in Netherlands, and who has also ongoing project with UK Biobank. So obviously, to use their data, you have to comply with GDPR requirements.
Absolutely.
So for that, we developed and installed a secure, compliant computing environment. It's a separate computing environment with storage system and separate compute systems and data movement networks, so that we can move data securely in encryption, in transit, at rest, and also being able to keep track of what's not on each individual data. We do that. At the same time, also, we have a project called DVR project. The goal is to share St. Jude cancer treatment tools and diagnostic tools and so on. Idea is that you collect samples from patient in some other country, and also send the sample to genomics diagnostic lab. And then once you get that genomic profile for the patient, then apply St. Jude knowledge and tools to understand the genetic profile, mutations, and regulatory pathway networks, and so on. Now, that's interesting question is that some country, if you look at data cannot leave their country, then how can you create data sharing network so that you share data to discover something, but yet data cannot leave the country, then how do you do that? So it requires a really careful architectural planning and also policy enforcement in place. But you gotta do that in a way that is not gonna impede your research progress.
And we talked a little bit about that yesterday, not impeding progress. Kind of coming back to the governance, what have you put in place so that you don't impede the progress, but yet you're still able to manage all of the compliance requirements?
So the team St. Jude team is working on to build this federated database schema, whereby data remains in the country, but you de-identify or anonymize if you need to move that data, or create kind of local compute instance whereby that St. Jude people in the country or people who has privilege to access data and to compute there, so they can do compute locally. And so whatever derived data that doesn't contain sensitive information would be populated into central database. So
It's fascinating.
Yeah. So it's a complex process.
It is a complex process. Stories like St. Jude have shaped how we've designed HPE Private Cloud AI. It is a foundation built for environments where data is sensitive, rules are strict, and AI still has to go through a full AI lifecycle. So in St. Jude, what shows up as one consistent environment your researchers can trust from development through training and training and into deployment? Where are you seeing that unified foundation change the way teams work day to day?
So before I answer the question, I'd like to talk a little bit about the AI journey we took. So St. Jude researchers have been using AI deep learning technology in their research for decades. But St. Jude did not have dedicated AI platforms to support that. So about 8 years ago, we started Journey with a few workstations that contains P100 GPU nodes. So everything was custom developed, model training, model development, inferencing, all custom. And there was no formal processes in place. And we quickly learned that we need a bit more powerful compute system to support that. So we brought on a DGX platform. And we tried to implement our own customized AI lifecycle management MLOps framework. Upon that, we learned that it's very time-consuming, difficult to use this, piece, put together, custom solutions.
Put all the components together.
It was very difficult. And our researchers, for example, did not want to use that system because oftentimes they have to move large volumes of data from other storage system into this object storage system dedicated for the DGX platform. So we learned that that's not the solution. So we were looking for a AI solution that comes with AI platform that comes with more of a complete unified end-to-end AI lifecycle management MLOps framework. So we looked around and there was a PCAI. So we brought on a small PCAI platform. We just run pilots on the system. What's good about the system is it's not only provide unified software stacks, but also it allows us to quickly deploy, for example, inferencing engine. Without, in old days that we had to, whenever we wanted to deploy inferencing engine onto our VM was separate GPU-based workstations. It took us a lot of time. So it really speed is matter. I think previous speaker talked about speed. So, and also that gave us, our researchers, kind of a trust. Yeah, you can use this system and be able to not only develop, but deploy inferencing pipelines, but you can actually keep track and manage your research experiments using this platform. So, hope that makes sense.
I love it. So for those of you who aren't familiar with Private Cloud AI, that is our turnkey AI solution, part of the Private Cloud portfolio, that is really designed to get up and running within days, focused on inferencing, RAG, fine-tuning, and with multiple t-shirt sizes, but it's really designed to make it very simple for all different types of people to use it. So I'm delighted for you to share that journey with us on PCAI. So let me bring it back to the question then. So in terms of what are you seeing that foundation, how has it changed the way that your teams are working day to day?
So teams are increasingly been more collaborative. So we have many projects going on. So they were using, one team was using different tool, this team was using different tool, and really, or scattered silo. And teams are increasingly collaborating with each other and using the tools that's available in PCAI to do what they need to do. That's one thing. So that really speed up time to bring ideas to actual experiments. That's really important. Time to experiment, accelerate it. And that is really enabling our scientists to innovate and also do a bit more discovery science.
I love it. Time to value is so important. I'm watching the clock, and I need to wrap us up here. As you look forward, what do you see the possibility for your teams going forward that may not have been possible a year ago in your partnership with HPE?
So, I look at my team, and my team work with research researchers throughout campus. And again, collaboration and also scalability. You have this AI workload that can you scale that quickly, the scalability. Right. And also, if you develop something deploy, can you trust it? So for example, a protein dose calculation, if you deploy that, a new patient comes and you push that data into this, what comes out of, can you trust that? Mm-hmm. I think we'll have more trust using unified framework.
Unified framework, absolutely, I completely agree. So thank you so much for your time. I appreciate you spending and sharing some of the stories with us today. Thank you. I have a little bit of background before I came into this world in research, and I have so much respect for the work that they're doing and how important this technology is to actually advance treatments for pediatric situations. I hope you all were able to appreciate that as well. So hopefully what you heard from both Bosch and St. Jude really reflects two different worlds. They're trying to solve two different problems, but the challenges are similar: cost, compliance with respect to data, performance, and availability. When you unify the governance and the data and the full life cycle under one operating model, you heard from both of these speakers that their teams are able to move faster with higher confidence. That's really what I believe is the promise of private cloud. As we wrap up here and you go on to the rest of your day, I want to leave you with one thought. All of you are likely dealing with the same set of underlying pressures, different problem set, but similar challenges. The way you move forward depends on that foundation that you build and what you're able to empower your teams on. You just saw two very different organizations face different problem sets, but solve that with HPE private cloud. I encourage you to spend some time on the show floor, what time is left here, to look at what we have in our private cloud portfolio and welcome the opportunity to discuss it with everybody. Thank you for your time today. Enjoy the last few hours, and I hope you all have fun at the celebration tonight. Thank you.